Alright, just like yesterday, we're on chapter 11, topic 7. So just like yesterday, how we could use these trig ratios to find a missing side, we can also use these trig ratios to find a missing angle. Okay, it's a little bit different how we do this. So in right triangles, you can find the measure of a missing angle by using the inverse function of a given trig function. So you can use the inverse of sine, the inverse of cosine, the inverse of tangent. Alright, make sure you are in the degree mode. So find the measure of angle C round to the nearest tenths. Okay, so let me copy my triangle here. So I got A, whoopsie. A, I got B, I got C, here's my right angle, here's angle A, so I got 10, I got 8. Okay, so it says find the measure of angle C. So I don't know why I marked A here. So the angle I'm concerned with is C. I want to know the measure of this angle. Okay, so to this angle, this is the opposite side, this is the hypotenuse, and this is the adjacent side. Okay, so I have the opposite side and I have the hypotenuse. So that's going to be sine. So I've got sine of C is equal to opposite over hypotenuse. Okay, so sine of C is equal to 8 over 10. Okay, so this doesn't seem to help me that much, but however, I can use the inverse function to get rid of this sine, okay? So if you take the inverse function of both sides, so for instance, if I take the sine inverse of this side and the sine inverse of this side, well then sine and sine inverse cancel, and I'm left with the degree, or the angle C is equal to the sine inverse of 8 over 10. And I can put this into my calculator because there is a sine inverse button. So I'm just looking for sine inverse of 8 over 10. Okay, so let me put that in my calculator. Sine inverse and this calculator doesn't have it, actually. So let me use the Desmos calculator. Okay, so sine inverse of 8 over 10 is 53.13. So what did it tell me to round it to? The nearest tenth. So that means angle C is 53.1 degrees. Okay, so angle C right here, 53.1 degrees. Okay, so we can use these inverse functions to help us calculate the angle. Okay, so that's how you get rid of a sine by itself. Okay. So 53.1 degrees. Alright, so once again, looking for the missing, or the angle here. Some x degrees, we'll call this angle theta. 13, 33. It says find x. So x is the measure of the angle, it's the value. Okay, so we're referring to this angle. So this would be the opposite side of that angle, this would be the adjacent side, and this would be the hypotenuse. Okay, so we have the adjacent, we have the hypotenuse. Adjacent and hypotenuse is cosine. So we know that cosine theta is equal to the adjacent over the hypotenuse. That's the trig ratio. Okay, So we have cosine of x degrees, which is, that's the value of theta, x degrees, is equal, well, you know, actually we could just leave it as theta, because we can calculate theta, honestly. Cosine theta is equal to adjacent over hypotenuse, so adjacent is 13 over the hypotenuse 33. And then we want to know the measure of this angle theta, okay? Which means we need to get rid of this cosine. So we can take the inverse function of both sides. And that actually cancels out the cosine to just leave us with the theta. So theta is equal to the inverse cosine of 13 over 33. So the measure of this angle here would be inverse cosine 13 over 33. So let's see what that is. (13 over 33), so that's 66.8. 66.8 degrees. Okay, so theta here, 66.8 degrees, which means that the value of x would be 66.8, because that angle measure is supposed to be x degrees, and the angle itself is 66.8 degrees, so x is 66.8. Alright, find x, round to the nearest tenth, so same thing. We're just looking for that missing angle there, and we can use the inverse function to help us do it. There's x degrees, 10. Okay, so this is the angle we're concerned with, theta, which means that to this angle, this is the opposite side, this is the adjacent side, and this is the hypotenuse. Okay, so according to SOHCAHTOA and the information that we have the opposite side and the hypotenuse. So opposite and hypotenuse, that would be sine. Okay, so the sine of that angle theta is equal to the opposite side over the hypotenuse. Okay, so sine of theta is equal to the opposite side 4 over the hypotenuse 10. Okay, now I'm trying to figure out what this theta angle is, so I can get rid of the sine by taking the inverse. Okay, that will cancel it. I just need to make sure I take the inverse of the other side as well. Okay, so that cancels that. So I have theta is equal to the sine inverse of 4 over 10. Alright, let's go to my Desmos calculator here. So sine inverse of 4 over 10 is 23.57, so 23.6 degrees. Alright, so this angle theta is 23.6 degrees, which means the value of x is 23.6. Because that says x degrees, so x is 23.6. Alright, we got two more. Use the trig function to find the value of x. Okay, so same, well, actually, we're looking for a side here. So x, 9, 7-degree angle here. Here's our 90. Okay, so here's our angle theta. That's the angle that we have. So to this angle, this would be the opposite side, this would be the adjacent side, this would be the hypotenuse. So right now we have the adjacent and we have the opposite. So that's tangent. We have the information for tangent. We know that tangent theta is equal to the opposite over the hypotenuse. So of the information we have here, we have tangent of theta, theta is 70 degrees, is equal to the opposite, which is 9, not the hypotenuse, sorry. That's the opposite over the adjacent. I don't know why I wrote the hypotenuse. So the opposite, which is 9, over the adjacent, which is x. Okay, so we solve this for x, so we need to get it out of the denominator, so multiply both sides by x. So x times tangent of 70 degrees is equal to 9. Divide both sides by tangent of 70 degrees. So x is equal to 9 over tangent of 70 degrees. Okay, so we'll put that in the calculator. 9 divided by tangent 70 degrees. That's 3.3 if we round it to the nearest tenths. So the side length here of this adjacent side is 3.3. And then lastly, once again, we're looking for a side length. So this is a 32-degree angle. So this is the angle that we have. We'll call it theta. The sides that we have, so this would be the opposite side, this would be the adjacent side, and this would be the hypotenuse. We have the opposite side and the hypotenuse. So that's sine. You know that sine theta is equal to the opposite side over the hypotenuse. So we got sine theta, we have theta, it's 32 degrees. We have the opposite side, it's x, and we have the hypotenuse, which is 8. We solve this for x, so multiply by 8 on both sides. So x is equal to 8 times the sine of 32 degrees. Alright, so we're going to round that to the nearest tenth, so 8 times sine of 32. So that's 4.239, so just 4.2. Alright, so that length over there, 4.2. Alright, so these trig functions, very useful for helping you figure out certain information about these right triangles. Alright, and here's the assignment for this topic here.